All right, good morning, everyone. So my name is Joel, and I'm an engineer at GitHub. I work with good friend Aaron, who's also speaking here. So creativity is the ability to imagine something new. It's not the ability to create something out of nothing, but to generate new ideas by combining, changing, or reapplying existing ideas. So today we're going to do just that. We're going to take some ideas from React, we're going to reapply them in Ruby on Rails. And in doing so, we're going to take a template in the GitHub application that is hard to test thoroughly, is impossible to audit with code coverage tools. Thank you. A little closer. How's that? A little better? All right. It makes it difficult to reason about data flow and fails basic Ruby code standards. We're going to go through a refactoring process that we actually did in our application to build a new piece of Ruby on Rails called Action View Component that allows us to test our views thoroughly in isolation, audit them with code coverage tools, and build them in a way that they only receive the data they need, in a way that is compliant with the standards we expect out of Ruby code. And it's also 200 times faster when we run our tests. So first, I think it'd be important for us to talk about what views really even are. Views are functions. They take data and they return HTML. So how has this looked in Rails over the years? You know, it's kind of been the same since Rails 1. Rails still ships with ERB just like it did in 2004. Rails 4 added turbo links in 2012. And in Rails 5, we got API mode in 2016. Or 2016. But in the last couple of years, I think as you probably have all seen in the landscape, things have really begun to change. I think it's telling that when DHH released Rails 5, he said something pretty damning. Rails is not only a great choice when you want to build a full stack application that uses server-side rendering of HTML templates, but it's also a great companion for the new crop of client-side JavaScript or native applications that just needs the backend to speak JSON. I think for most of us, the history of the Rails view layer is one of most of us moving away from it. So what does the view layer look like in the GitHub app? We're still using ERB. So you might wonder, why isn't GitHub like a React, Angular, or whatever, single page application like probably most of you are building, these days. And the reason is progressive enhancement. So while in our app JavaScript makes the user experience more enjoyable, most of our app works without it. Try turning it off sometime. So why do we do this? Besides just a ton of legacy code, one of the main reasons is performance. Most of us here in this room are really lucky to be using modern, powerful iPhones and Samsung devices, but a lot of our new users are in developing countries and they're using lower powered devices that buckle under heavy JavaScript. Another reason is browser support. So since we don't need JavaScript to run our site, we can just turn it off for most browsers, allowing us to focus on the most modern ones, making it a lot simpler to maintain. So how do we do it? We do this with a couple tiers of JavaScript bundles. This is the actual code. This is from Application Controller RB. So we have a fully supported browsers. They get these normal bundles. We send polyfills to a couple second tier browsers. And then for the rest, we just send a smaller set of polyfills. So as we deprecate browsers, we move them through these basically 3 tiers of support. So what does this look like in practice in our architecture? So let's take the most basic core use case of using GitHub, leaving a comment. So when you click the comment button, JavaScript intercepts the click on the comment button, and an AJAX request returns 3 DOM nodes. One for the sidebar, one for the comment format, and one for the timeline. We then inject those results into the page. You can think of this as something very similar to turbo links. No coincidence. What's great is that if JavaScript is turned off, we just do the typical request response cycle. So what is it like to be an engineer working on views at GitHub? So we're going to tell the story today of working on a specific new feature that came out in January, which was the sticky headers for issues and pull requests that I worked on. As part of that project, I got to work on this little piece of the user interface that you see all over the app that we call the issue badge. And we use this issue badge to display the status of issues and pull requests. It's part of our design system that we call Primer, which you can think of as literally just Bootstrap, but for GitHub. We actually employ the guy who made Bootstrap. No coincidence there. I think he had a strong effect on our design system approach. So before we dig into that, let's look under the hood of the GitHub codebase a little bit and talk about our data model. So this is a very simplified version of our models, but basically a pull request is just an issue with an associated pull request object. And this will be important to know later. So all pull requests are issues, but not all issues are pull requests. And we render that little issue badge with this partial. I'll give you guys a second to read it. This is the actual code. Not anymore. There's something better. But this is literally what was in production when I started writing this talk in January. So depending on the state of the pull request or issue, right, we render an icon, label, and a color. And these together display the state of an issue or pull request. So wanting to know more about how this template worked, I figured why not I just delete it and see what happens with CI. So that's just what I did. And I pushed it up. Oh god, and it was green. And that's how I knew it wasn't going to be so simple. So you might wonder, like, how could this be, you know? I think you can all imagine working on Ruby on Rails at GitHub is different. GitHub is a Rails monolith that just turned 11 years old, which is crazy. What does that say about Rails, right? Like, same code base for 11 years? We have over 200 controllers, and this doesn't include our API. It's completely separate. We have over 550 models. What I didn't even list here is we have over 1,500 concern files, which are included in those models, so this number is a lie. And we have over 3,700 view files, and this includes partials that we reuse, just like, right? Like, no one is ever going to keep track of all of this. So I think it's pretty obvious, but like, this scale really affects our approach to writing tests for our views, right? Like, how, you know? So right now, our main way of exercising our view code in our tests is through controller tests that we've set up to render views, which isn't great. In our test suite, it takes 6 seconds just to execute the body of a controller test that renders a view and like asserts against the content. That doesn't include any setup of any sort. That's literally just like in between like the it and the end of a test assertion. 6 seconds. So if you ran 10 tests, that's 1 minute. We have 3,700 views. If we wrote just one test for every single view, that's a lot of time. So I think we can agree that that's like really not ideal, right? Let's go with that. The thing is that looking at the way Ruby on Rails works at the scale of GitHub, I think that it's actually kind of great as an engineer because a lot of the problems you might think, a lot of things you might think would be a problem are just really obvious, right? Because the scale is so big, everything just becomes like pretty clear. And I think that like this general shape of our application exposes a couple shortcomings in the view layer as it stands today. So when I asked my local Ruby group back in Colorado, what trips you up with Rails views? The #1 response to that question was pretty simple. Data flow. And a common data flow error I think we probably all made in our views is the n+1. You know, where you accidentally generate an expensive query in a view. So our example code also has some data flow issues. So if we look at our example here, for pull request and issue, what attributes do we need from each of these objects? If these are active record objects, we'd be fetching their entire set of attributes, when we may in fact only need 1 or 2 from each object. You know, it's also unclear where these pull request and issue variables are even coming from, which makes it difficult to reuse this partial with any amount of confidence. So another problem with testing views is that unit testing them isn't a common practice in Rails. Rails encourages us to test our views through integration and system tests, which, like our controller tests, are very expensive. You know, this gets really painful for partials like this one, as they often end up being tested for each of the views they're included in, which leads to duplication of tests, and I would argue kind of like cheapens the benefit of using partials in the first place. You know, another problem is measuring code coverage. The 2 common tools, SimpleCov and coveralls, don't support measuring coverage for view code. This combined with how hard it is to write thorough tests and how expensive it is to write thorough tests puts our views in a blind spot when you compare them to the rest of the code that lives in our applications. Another weakness is the lack of an explicit method signature. So if you can imagine like a method declaration on a Ruby object that has like explicit arguments versus views, they don't declare the values they're expected to receive. So when you look at that partial, you actually don't know what the expectations are of running that code. So let's go back to that example. You know, what data does this view need to render? Does it need a pull request? Does it need an issue? What happens if I pass in both of them? What happens if I pass in neither? You know, are these values passed in as locals, or do they come from some sort of global, global helper or something like that? The thing is that our views regularly fail even the most basic code standards that we expect out of our Ruby classes. So let's do a contrived example. Let's take that template and make it a method on a class, so we can put it in the context that we review our regular code. So if this was a method on a class, what might a code review look like? You know, besides it being a really long method, I can think of a couple objections we might have. So we have this method octocon that's called, but it's not defined here, and it's not clear where it comes from. You know, where does this class attribute value come from? It kind of feels like a magic string. Where are these pull request and issue variables coming from? The reality is that we regularly do things in our views that would never even pass code review in a Ruby class. Kind of feels weird, doesn't it? So to recap, Rails views are difficult to test, and those tests are impossible to audit with code coverage tools, preventing us from knowing how thorough they are. They make it difficult to reason about data flow, have implicit method signatures, and often fail basic Ruby code standards. So these things make the Rails view layer more of a second-class citizen these days. And you know, given all of this, I don't think it's much of a surprise to any of us that a new way of building views has taken hold in the Rails community. React. So React is all about components. How many of you here work in React on a regular basis? Good, so this explainer will help. Okay, so a component is an object that encapsulates a piece of user interface. So here's one way of writing a simple hello world component. So React components, at a minimum, implement a render method that returns HTML. Arguments are passed to a component and then are assigned to a props object, which is then accessible within methods on the component. So here's an example of what the issue badge might look like as a React component. Forgive me for oversimplifying. So like our template, the component renders an icon and a label wrapped in a state-specific CSS class. Another cool thing about React is types. This has changed a lot over the past year or so this is a little out of date, but this library still exists. There's a library called prop types. This used to be part of React, now it's actually been extracted out. But allows React components to express some expectations about the data they receive. So in this case, we're expecting an issue with the isClosed boolean to always be provided, and a pull request to sometimes be provided, but if it is, with the is closed, is merged, and is draft booleans. This allows us to reference the is closed boolean on issue without worry, as that type check guarantees that it is present. So another advantage of React and a lot of other front-end frameworks is how it simplifies data flow. Because we have to pass values into our React components instead of like rich, say, active record objects, React encourages us to write functions that don't have side effects. Another cool thing about React is how easily components can be tested in isolation. So here's an example of a React test that renders our component directly and then asserts against the output. So what's great is that this test runs without touching the database or the controller layer. So as you can imagine, it's really, really fast. So to recap, React has components that render HTML, types that give us confidence in our inputs, simplified data flow, and lightweight testing in isolation. Which is really too bad because at GitHub we do progressive enhancement, which means that we can't use React. But we were wondering, what if there was a way to incorporate some of the architectural benefits of React into Ruby on Rails? So how about we do some refactoring? And to do that, we're going to need some tests. So let's add a couple, make sure we don't break anything. So what might it look like to test this view today? In each case, we're doing three things: setting the class name, icon, and label. So to start, let's add some of those traditional controller tests for each state. This is more or less how we write our tests in our application today. So we'll start with a test for the open issue badge. And we'll assert that we have the correct class name, icon, and label. And now we have test coverage. So now let's delete the view and see what happens this time. We have failing tests. Imagine that. So now we can do some refactoring. So what might a view component look like in the Rails world? Well, as that sticker in the last, in one of the sponsor talks earlier today mentioned, everything's an object in Ruby. Why don't we make our views objects? Bit of a stretch. I think it would make sense to make it a class. So let's call it badge inside the issues module. And how might we call it in our view? I think the Railsy way would be to use our existing render syntax. So let's see if we can get that first test to pass. We'll add a method on our component object that returns the open issue badge from our partial. Then we'll run our test. So here's our first error. It looks like ActionViewRender doesn't like being passed our component. So let's teach it how to handle it. Now, short of forking Rails and changing the original definition of ActionViewRender, let's write a monkey patch. It's Ruby, right? Like, that's what we do. Monkey patch-driven development. So in our monkey patch, we'll redefine render so that we pass in our component, literally our component. It calls our component's HTML instance method. So let's run our test again. Undefined method octagon? That's starting to sound like our code review. Remember that comment about not knowing where the octagon method came from? Now our code is asking us the same thing. I think that's pretty great. So back in our component, let's tell it where to find it in our octagons helper. And let's run our test again. Cool, so we got a new error. That's good. It can't find the CSS we're looking for. So let's look and see what our component is rendering at this point. Oh gosh. So this is unescaped HTML. Probably not ideal. At this point, I think it's pretty obvious that building views is not just string interpolation. So instead of trying to reinvent the wheel, what if we just use the existing Rails rendering pipeline? So to do that, we're going to need to move our template into a method called template. And then in our HTML method, we'll run our template through ActionView's existing ERB template handler. This basically mirrors exactly what Rails templates do today, which is they are compiled and then executed. And then we'll run our tests again. And we're green. We got a working component. So let's keep moving along. This next test is for a closed issue. which should have a red background, closed icon, and a closed label. So let's run it. And it looks like we're missing that state in our template. So let's go back and update it. Now, while we're already passing the issue into our component, we aren't doing anything with it yet. So let's change it. And to do that, we're going to need to take our monkey patch, and we're going to need to take those arguments and pass them into our component's initializer. And then we'll need to define an initializer on our component. And if you remember back to our data model, we'll let pull request be nil, as not all issues have pull requests. So now that we have an issue, we can reference it in our template, like so. So let's run our test again, and we're green. But did you see what we just did there? We gave ourselves an interface, which means we don't have implicit arguments for our view anymore. And just like that, we're making progress on that code review. So next, let's just take the rest of the template and drop it into our component and see how the rest of our controller tests do. And they're green. But something doesn't seem right about this template. The first 2/3 handle various pull request states, while the last third handles issue state. It seems that we really have two components here, not one. So since the view that calls our component knows whether it is dealing with a pull request or an issue, how about we split this out into two components and let the view pick which one to use? Now that's not so bad. Based on whether the issue has a pull request, we can render either the pull request badge or the issue badge. So back in our monkey patch again, we'll need to update our conditional to look for both components. So let's check our tests. We're still green. So let's look at our code review some more. So remember that comment about magic strings? Both our issue badge and our pull request badge are rendering the same state UI element from our design system. So why don't we make that a component? So our state UI element really just has one option, and it's color. So if it was a component, that would be our single argument. So let's build it. We'll call it state inside the primer module. And then we'll also need to update our monkey patch to handle yet another component. But as I guess you can say, this doesn't feel right. I don't know about you, but this line of code to me says missing abstraction. What this line of code is trying to say is this a component, right? So I think that it's time for a parent class. It's time for action view component. So let's take our new parent class and update our existing components to inherit from it. And then we can simplify our monkey patch to just check if the argument is a subclass of action view component. So now that we have a parent class for our components, let's try to reduce some duplication. An easy candidate is that HTML method, which does not have any component-specific logic. So let's move that into action view component, and then we'll run our tests again. We're still great. So back to building this new component. You know, this one's a little different. We're passing it content as a block. So let's start by writing a test. Now, while we could probably just rely on our existing controller tests to cover this case, wouldn't it be nice if we could test this new nested component by itself? So in React, our tests were able to render our component directly and then assert against the resulting HTML. And ideally, we'd be able to do the same in Rails. Render the component directly and then assert against the resulting HTML. Now, all we would need is a way to render a template in line, which it turns out is pretty simple. We can do it via application controller, rendering our template in the same code path as a normal view, and then parsing the result in no-cookie so we can make some nice assertions against it. So let's run our test again. It sounds like something that expects a hash, that expects a class, is receiving a hash. And it looks like our test helper is actually the problem here. It's passing a hash into render. So as it turns out, in writing our monkey patch, render accepts arguments that are of different types. So we need to go back to our monkey patch and add a type check to make sure we're dealing with a class. And then we run our tests. 15 minutes left. Thank you. So there we go. So we have an error now that we're expecting our content to be rendered, but we just got an empty string. So let's think about how we might make this work. When we're passing content to our component, what we're effectively saying is render this block in the context of the current view, and then wrap the result in the component. So what might it look like to make this happen? So first we'll need to update our monkey patch to accept a block argument. And then we'll need to update our render step to first instantiate the component, and then, if a block has been passed, render it in the context of the current view using ActionView's capture helper, and assign the result to an accessor on the component. At that point, our component will know about the content, so we can render it. So since we're expecting all components to now have a content accessor, we can go back to ActionView component and declare it there. Then it's just a matter of taking our component and updating the template to render the value of the content accessor. So let's check our test, and we're green. So now that we have content, what about setting the color? So let's start by adding a color argument to the initializer. But what color values do we need to handle? So let's look at our documentation. Luckily, our design system has pretty thorough, somewhat up-to-date docs. It looks like we can specify 3 different colors: green, red, and purple. Otherwise, the component defaults to gray. So let's go back to our component and capture those relationships in a constant. This gives us a clear mapping between the default value in not applying a CSS class, and between the color values in the respective CSS classes. The keys of our hash, interestingly enough, also represent the entirety of the values we should allow for the color argument. So how might we enforce that on our component? So let's start with a test. First, we'll assert that when passing in a color that we're not expecting, chartreuse, that an error will be raised, and with a message in a format that should be suspiciously familiar. So let's run it and make sure it fails. So how might we ensure color is one of our expected values? Well, we're in Rails, so this is a solved problem, and it's called active model validations. So back in our component, we can use an inclusion validation to check that color is one of the keys in our constant. So to make this work, we'll need to define an attribute reader. In an ActionView component, we'll need to include active model validations. All that's left is to go back to our monkey patch and add a step to validate our component before we render it. So let's run our test again. We're back to green. So now let's add a test to make sure we're setting the right CSS class based on the color, and then our test fails. So previously we just had the CSS class hard-coded, but now that we can be sure that color is one of the keys in our hash, we can safely use that hash to look up the correct CSS class and use it in our template. And we're back to green. So let's take another look at our documentation for our design system. I think we might have missed something here. We're supposed to have a title attribute. For most of our design system components, CSS classes are not the entire interface. But this is something our original partial had completely missed, and something that's really important for accessibility. So let's make sure this doesn't happen again. And we'll do that with a test that passes in an empty title and expects a validation error. And we'll make sure it fails. Then it's just a matter of adding a presence validation for the title attribute. And we're back to green. So let's see how our controller tests fare. Missing keyword title? I think we just caught a regression that we just introduced. We never updated our consumers of that component to pass in that required title argument. So we'll add the title attributes, and we're back to green. We're doing TDD for views. It's great. So when it comes to data flow, we are mainly concerned with our views unintentionally querying the database. But what if we could avoid passing in active record objects at all? That would eliminate that risk. So let's start with the issue badge component. Right now we're passing in an issue, which is an active record object. But the only thing we're doing with it is calling the closed predicate method. So as you can probably imagine, issues interface is much bigger than just this one method. But we're passing in the entire object just to get this one value. So if we look at the implementation of the closed predicate method on this very abbreviated Rails model, it's just checking whether the value is closed. So what might our component look like if we passed in the state value instead of the whole issue object? So first we need to update the initializer to accept the state value instead of the issue object, and add a validation for the values we expect. And then looking at our template, what if we extracted each branch to then be derived from that state? We could express the relationship in a constant, much like the primer state component. And that would express the relationship between the state and the combination of color, icon name, and label. Then we can take our template and extract the values from that constant instead of having nearly duplicated branches in our template. So let's run our tests. We're back to green. But what about that pull request component? How might we decouple it from active record? So if we look at that template, we're relying on 3 predicate methods: merged, closed, and draft. So can we pass in a state value like we did for the issue component? If we look at this, again, very simplified pull request model, things aren't as simple as they were for the issue model. While we do have a state value, whether the pull request is a draft or not is actually just a Boolean in the database, which means that we're going to need to pass both of these values to render the pull request component. So let's start with some tests. In this first one, we'll assert that when we pass in state and isDraft values that we render the correct label, title attribute, and icon. So let's run them. It looks like our component is still expecting an object. So let's go update it. We'll update the initializer to accept the state and isDraft values instead of the pull request object. Then we'll take our template and extract the title, color, octocon name, and label into methods. We'll take a good look at this for a second. Do you remember our React mockup from earlier? It's pretty similar, huh? It's almost uncanny how much the React architecture is able to be applied in Rails so cleanly. So let's see how our tests fare. We're back to green. So remember how React encouraged simple data flow, minimizing side effects? By passing values into our components instead of objects, we're seeing very similar benefits. And remember how we were unable to get code coverage reports for our views? Our app now has a perfect score in simple cutoff. And if you look at the report more thoroughly, we now have proof that all the branching logic in our pull request component is being exercised by our test suite. So what about performance? What might a useful benchmark be? When we're building UI with components, there's a lot of nesting. And traditionally, rendering Rails partials in a nested fashion hasn't been that fast. So for us, the most critical benchmark of making this a viable architecture is the speed of rendering significantly nested partials. So given a partial that wraps the content to it in just like a simple box element from our design system, and a component that does basically the same, let's build a stress test. And we'll do it using Evan Phoenix's benchmark IPS gem. This is like our standard internally for measuring performance of code. We'll render 10 nested box components and 10 nested box partials and compare the result. And as it turns out, with our very rudimentary implementation, rendering components is 5 times faster than partials, which is awesome. So what about test performance? Remember how controller tests were taking us 6 seconds for each render and assert setup? These new unit tests are 25 milliseconds, which I'm not great at math, but that's 240 times faster. Imagine if you could write 240 times as many test cases for the same cost. You'd probably write more tests. So what are we waiting for? Let's ship it. I mean, it's a monkey patch, right? What's the worst thing? So as it turns out, this monkey patch has been running in production on GitHub since March. And this is monkey patching render, which that gets called more than one time per request. And we're seeing edge requests of between 30 and 60,000 per second in our Rails app. If it works for us, it'll probably work for you. And since then, we've built a couple other components. Anytime you see these little repository topic badges, or the little circle with a very controversial color for the language and then the name of the color, that is all rendered with components, in addition to every single place you see the state of an issue or pull request anywhere in the app. So what have we learned so far? Well, we've simplified the API a little bit. So if you look at our monkey patch, we were taking the arguments and then almost immediately just passing them right in to the initializer for the component. And this indirection ultimately just kind of felt unnecessary. So we removed it. So instead of passing the component arguments after the component name, we just instantiate the component with the arguments before passing it into render. We also ran into an issue with those inline templates. Support for syntax highlighting here docs is not universal, and by not universal I mean we don't do it. So we can't expect anyone else to. This is on .com. We don't highlight that ERB, right? We also found that having a template inline in a component got awkward when the template was more than like a dozen lines or so. So with these problems in mind, we added the ability to take that inline template and just define it in a sidecar file instead. So this would be like the pull request badge HTML ERB file. But perhaps the most exciting thing we've come up with in learning about all this is about convention. So you know how a lot of Rails apps end up with a couple unconventional folders in the app directory? There often ends up being one that is view related, right? You know, it's a place to put logic that doesn't make sense in the traditional MVC architecture. Usually it's something like presenters or decorators or view models, right? Ours happens to be view models, and we have 700 of them. And taking a step back and thinking about this pattern across many of the Rails apps I've seen it in, it kind of just feels like a missing abstraction. So if we're doing it in all of our applications, but Rails doesn't provide a way to express it, something's wrong. But luckily, we think we found the abstraction, and that it's called Action View Component. So our current experiment is seeing if we can replace view models with components. And the results so far have been very encouraging. The first migration we did was creating a component for a repository list item, which we had implemented the almost exact same way, I think a half dozen times throughout the app. Some of them used view models, some of them didn't. But now we have one implementation. So anytime, anywhere in GitHub you see a list of repositories, we are working towards making that implemented with a single component. So what's next? We've already started work to upstream this project into Rails. After sharing it at RailsConf in April, Raphael from Rails Core asked us to upstream it into the alpha branch of Rails 6. So here's the patch that just landed about a month or so ago. It adds support for passing in an object that responds to render in. And so if render in is called in the object, if render in is called in the object with the current view context and the pass block as arguments. This basically is an upstreaming of the most critical piece of our monkey patch. We still have the monkey patch. So our plan is to continue to upstream more of our implementation. By implementation, I mean monkey patch, as it stabilizes internally. So creativity is the ability to imagine something new. It's not the ability to create something out of nothing, but to generate new ideas by combining, changing, or reapplying existing ideas. By taking ideas from React and incorporating them into Rails, we've taken a view layer that is hard to test efficiently, is impossible to audit with code coverage tools, is difficult to reason about data flow, and fails basic Ruby code standards, and created a new way of thinking about the view layer in Rails that enables us to write efficient, isolated tests that are audited with code coverage tools, only work with the values we need, and follow the code standards of the Ruby language. All of these things have given us a higher level of confidence in our view layer, and perhaps most importantly, have made it a first-class citizen in Rails. Thank you.
So if you have any questions, please speak to the speakers after the session. And Next, we'll have lunchtime. So our afternoon section will start at 1:25 and this room 1:25. And for lunch section, you can go collect your lunch box at a reception area. Sorry, at a conference area, basically. And there's a metal lunch box. Please return the lunch box back to the staff. Do not take home, okay? I repeat again, do not take the metal bento box back home. The lunch box, do not take it back home. Okay, 1:25. And also there's at afternoon about 3:30ish, there's gonna be an autograph time from Matsu-san. Okay?
Is that all the time?
It's always photo and autograph and photo and drinking and autograph. That all the time.
Guys, I have so many GitHub stickers, you should come take them from me. I literally dropped like hundreds of stickers.
Okay, if you want GitHub stickers, come and ask a question.
Yeah.
Yes.
You don't have to ask a question, you can just, the question can be, can I have a GitHub sticker?
Okay, you get a sticker.
And I'll spoiler, the answer is always yes.
So if they ask good questions, they get more stickers.
Yeah.
Okay, cool.
There's no limit on stickers except the number I have.
Okay.
So share, I guess.
Okay.
I got like 300. There's not 300 of you, right?
Oh, yeah, well.
Yeah.
We'll all get one.
Okay.
Yeah. Okay, great. Big round of applause.